If switches are the backbone of local area networks, routers are the backbone of the internet. There are millions of routers around the world. Routers move packets between networks. That's their job. So I'm going to jump down to the hands-on portion of this exercise, and we're going to add a router to a bigger network. All right, so I've got Packet Tracer running. I'm going to add two 2960 switches to the network. So I'm in Network Devices. I want to go to the Switches subcategory. I'm going to add a switch called Data Center. So maybe this switch lives in the basement of our headquarters building. And then I'm going to add a Workstations switch. Maybe this exists on one of the main floors of our office building. All right, so we've got two 2960 switches there. That's good. I'm going to go to the End Devices category. The End Devices subcategory will be selected. I'm going to drag a PC there, and I'm going to change this label to Test User. And I'm going to use my lightning bolt connections. I'll use that solid black copper straight through cable to connect test user to workstations, and it says any of the fast Ethernet. So roll the dice, I'll pick 10. Doesn't matter which one you connect it to, honestly. So my PC is connected to the workstations switch. That's good. I need to add a server. So servers are in End Devices subcategory. I'm going to add a server here. And I'm going to change this to, say, web server. Now I should connect that web server to the data center switch. So I'll connect fast Ethernet 0 to whatever, 20. 20 is good. Doesn't really matter which you connect it to. Notice that this light is orange right now. The switch is trying to figure out what it's connected to. That's fine. It'll turn green eventually. Let's see, do I match? I've got my web server connected to the data center. Yep. I've got my test user connected to workstations. Yep. All right. Now this network is perfectly segmented. However, there is no connection between the data center and the workstations. So our user would not be able to connect to the web server at all because there's no connection. We've segmented the network, which is very secure, but right now this network is also extremely useless. So let's set the IP addresses and subnet masks for the users. So I'm going to click on test user. I'm going to go to config fast Ethernet 0. What's its IP address? 192.168.1, take note of that, .5. I'm going to hit tab. All right, so our PC is on the 192.168.1 network. I'm just going to call that the 1 network. And I'm going to close my test user. I'm going to click on the web server, go to config fast Ethernet 0, change the IP address the same way, but this time it's going to be, I got to move this over a little bit so I could read the instructions, 192.168.50.5. Hit tab, it'll fill in that subnet mask the way I want. So this web server is on a different IP network. I'll call this the 50 network. So I've got my users connected to one switch, their IP addresses are on one IP network. My web server is on a different network. It's on the 50 network. So if packets are going to go from my test user to the web server, those packets have to move networks, not just hardware. They have to move logical networks. So just trust me on that one. For now, to move packets between these networks, well, we got to cable them physically so that they're physically connected. We also have to configure a router so that router will move the packets from one network to the other. So I'm going to go to Network Devices, the routers subcategory, and I'm going to use the 1941 router. That's the hardware we have in our CyberLab, so I'm going to use it here. And I need a couple of cables. Notice they're going to go from gigabit 01 to gig 01. And from my data center, I'm going to go gig 01 to gig 00 on the router. So let's make that match. I am going to look at my connections. I'm going to use that same cable, that solid black line, the copper straight through. That'll work just great. So the data center, I'm going to go click on gig 01 to match my diagram. And on the router, I've only got a couple of options. I've got gigabit Ethernet 0/0 or 0/1. My diagram says I should connect this to 0/0. So that's what I'm going to do. I'm going to select another cable, same cable type, click on the workstation switch, and I'm going to go gigabit Ethernet 0/1 to the router. The only gigabit Ethernet connection left is 0/1, which is good. So if I rearrange these to match the diagram in the instructions, like it doesn't really matter how they're arranged, but this would be helpful. I don't have the labels here. I'll show you how to turn those labels on. In Packet Tracer, if I want to see those labels, the gig 01, all that stuff, it would be useful here to make sure I've done this correctly. I'm going to click Options, Preferences, and there's a checkbox. Always show port labels in Logical Workspace. I'm going to go ahead and click that and just hit the X to close these options. So now I see those port labels. So I see a gig 01, gig 01, gig 00, gig 01, all that's good. It doesn't matter on the switches if our web server and, oops, didn't mean to click that. If our web server and test user connect to different interfaces, that does not matter. The connections to the router matter. The connections to the router matter a whole lot. All right, this is good, but we got these red lights. Red lights means like they're not working. By default, the switches come with all their interfaces turned on, ready to go, ready to start doing networking, but the router's different. The router comes with all of its interfaces turned off by default. So that's fine. Let's go to the test user. We're going to verify that this does not work, so this is going to fail. I've got the test user PC open. I'm going to come to the desktop, the command prompt, and I'm going to try to ping my web server. So ping 192.168.50.5. And it's going to try, it's sending out a message, but that message cannot get to its destination. Essentially, no bueno. It's not going to get there. So yeah, it's not working yet. That's as intended, totally fine. We have to configure the router. So the router is kind of like just a computer, just highly optimized to move network packets. So I'm going to click on, I didn't rename my router. Routy make route face. That's my router. So I'm going to click on Routy make route face. And if we come to the config tab, we've got a couple of gigabit Ethernet interfaces here. I'll go to gig 0/0 first. So this is the one connected to the data center. So that's the 50 network. And I'm having some issues using my trackpad. All right, IPv4 address 192.168.50.1. Watch for typos. Make sure I got all those periods in there. I like the subnet mask. You'll see the actual configurations happen at the bottom of the screen. That's just fine. That's good. I'm going to close this just after I do one more thing. I need to check this box to turn this port on, and I'm going to move this out of the way. When I check that to turn it on, notice that light turned green automatically on the router's side. On the switch side, it turned that amber color. That'll turn green in a few seconds. But I can continue. I can click on the Gigabit Ethernet 0/1 interface on the router. So this is connected to the test users network. And I'm going to give it the IP address 192.168.1.1. Hit tab. Check the box to turn it on. It turned green, so that's good. All right, so is everything working now? Almost. I can wait for that to turn green. It'll turn green soon. Does that mean my network should work? The way we have the network set up now, the test user's computer has an IP address that is on the same network as this Gigabit 01 interface. So it's kind of like a computer-to-computer network. The web server has an IP address on the same network as the Gigabit 0/0 interface. So I'm going to open up the test user, and let's come to the command prompt. I'm going to hit the up arrow key to try that ping again. And what happens? Why doesn't it work? Why is computer networking so dumb? It's going to fail. So why does it fail? Well, we have to make another configuration change. This should fail 4 times because we have not changed one more setting that we need to do. We can do another failure test. I'm going to close the command prompt with this X here, and then I'm going to open up my web browser to browse the web site on the web server. But if I can't ping the server, there's a good chance that this is going to fail. It will fail. If we go http://192.168.50.5 and click go, it takes a while to time out fully, but this will also fail. That's what we expect to happen at this point. Request timed out. Okay, so what do we need to do? What do we need to do to fix this? Well, these computers need a default gateway. Basically what the default gateway says tells each device, hey, if you need to send a packet off of your current network, here's where you need to send that packet. So if this test user needs to send a packet off of the 1 network, we're going to tell it, send it to the router. Likewise, we're going to tell the web server, if you need to send a packet outside of the 50 network, just send that packet to the router. And the router is like the post office. The router is going to look at the address. It's going to figure out where to send that packet. All right, so I'm going to go to test user. This time I'm going to go to we're on the desktop tab, so I'm going to stay there on the desktop tab. We'll open up the IP configuration. Slightly different view than the config tab, but it's all fine. The default gateway right now is set to 0.0. It's all zeros. It's not what we want. We want to say 192.168.1.1. That's the IP address on the router. So we're saying you got to get off the network, send it to the router. I'm going to do something similar on the web server. So I'm going to open up my web server. I'll come to the desktop tab, IP configuration. Change that to 192.168.50.1. So that's the IP address of the network connection on the router connected to that 50 network. No save button, you can just close that window. We're good. So we're pointing the test user to the router, and we're pointing the web server to the router, but we're pointing to the closest interface where you can trace that cable connection. All right, so we've had a lot of failures. We need a win. We've got to get a win. So I'm going to come to the test user. I'm on the desktop tab. I'm going to open up the command prompt. I'm going to hit that up arrow key. Is this ping going to work? Sometimes the first one times out, even if it's successful. It timed out, but then it started working. All right, I'm going to try it again. All 4 should work this time. Sometimes it just takes a second for the devices to get to know each other, to figure out how to map everything. So in this ping test, the ping went from the PC through the switch to the router's GIG01 interface, out the router's GIG00 interface, to the data center switch, to the web server, and then it came back using that same path. So let's check the website. Is the website working? I'm going to close my command prompt in the test user, and I'm going to open up the web browser. And what do I get? It's very slow. It's very slow to start. If I just type 192.168.50.5, that's the IP address of the web server, it succeeds. I was able to load the web page from the web server. All right, so if it didn't work, double check that all your IP addresses are correct. If your IP addresses are correct everywhere, it should work just fine. But one small typo, if you did 192.16.1.5, everything's broken. Nothing's going to work. One mistake in any of these IP addresses and everything is going to lose its connectivity. This is not forgiving. So there's a few things that you can check. Just double check those IP addresses everywhere, and it should be good to go. So we extended our network, we segmented our network. We have multiple devices here. We could add more switches. We could add other networks. We can grow this network. The key idea here is that the router can move packets between my various networks. That can help our network scale. If we had internet connectivity, we would probably connect this router to our internet service provider's cable modem or something that's going to get us out to the internet. And then when those packets come back from the internet, those packets would be processed by the router, and the router is going to figure out how to direct those packets to the intended recipient. So routers are very important. Key idea is that they move packets between networks to make our networks scale. And these routers also help us segment our networks. So instead of having one big network, we can have smaller network chunks, essentially, to help with the security and performance of our network.